changing from, this should say standard to general. Sorry, it's backwards. It should be standard. The writing to general. They're the wrong way around. This is also called just vertex form, right? So why would we want to switch from standard to vertex form? Because vertex or general form gives us more information, right? It gives us our vertex, it gives us our concavity. The standard form just gives us our y-intercept and basically how it ends, right? Up or down. So we like having it into vertex form so we can get the vertex. So following along, please, so we don't lose you. And I'll explain why we do this. So at first, it might seem a little confusing, but you'll understand why in a second. Okay. So what we want to do is we want to get this to somehow have an A value in front, correct? Bracket squared plus a value at the back. That's what the vertex form looks like. That's what our whole goal is to do. So what we're going to do is we're going to write y equals, and then I do a square bracket. The square bracket will go away in a second because the vertex form doesn't have a square bracket, so obviously it's going to go away. Then you always write the number that's in front of this, in front of your leading coefficient. So basically your leading coefficient you write. So it's a 1. I write the 1. Now the square brackets are a little bit redundant when we just have a 1 in front. However, if you always just do it the same way it works for every single example, then you're not trying to be like, do I have to do the square brackets this time or not? So I always just do it the same every single time, so you're not trying to figure out which way do I have to do it when it's like this. So I write my leading coefficient in front, okay? Then I put a bracket, and I write x squared plus 6x, just the first two terms. Now I didn't have to take anything out of them, because if I write the leading coefficient here and it's not a 1, say it was a 2, I'd have to take a 2 out of these in order to have that bracket there, correct? But I don't have to because it's just a 1. Now I'm going to go plus blank minus blank, and I'm going to explain to you why we do this in a second. Square bracket plus 8. The reason why we plus blank minus blank is we need to get something into this blank so that when I factor this, it's a perfect trinomial square. Okay, what the heck is a perfect trinomial square? You learned it in grade 10, but it probably left. Okay, if you have x squared, let's go plus 2x plus 1. It's a perfect trinomial square because when I factor it, it's what multiplies to give me 1 and adds to give me 2, x plus 1 and x plus 1. So it's a perfect trinomial square because I actually have two terms that are the same, and I can turn this to x plus 1 squared, correct? So I'm going to try and figure out, hey, what could I put in this blank so that this forms into two factors that are the same so that I get this x minus p squared or x plus p squared. Okay, that's all we're doing. The easiest way to find that blank, so I go blank equals, it's always b divided by 2 squared. And your b value is always the one beside your x. So what's beside my x right now? 6. So I'm going to go 6 divided by 2 squared, which is 3 squared, which is 9. Because if I take this value and divide it by 2 and square it, I'll get a number that I can make this to be a perfect trinomial square. Okay? So now why do I have 2 blanks? Why would I have 2 blanks? Because I can't just randomly add a 9 to an equation and say the equation's the same. Okay? You can't just add a 9 to it. You have to take the 9 back off. Then people are like, well, why would I add a 9 if I'm going to take it right back off? That's just stupid. Because you're putting the 9 on here with this, so you're actually going to factor this, and you're subtracting the 9 off, but you're not going to go add the 9, subtract the 9, put it back to 0, and be right back to square 1 again. You're going to use this 9 now, bless you, to make this a perfect trinomial square. And this 9 you have to just subtract so that the equation is balanced. Okay? So why do I do the square bracket? Because this number out front here, this 1, is multiplied by the 9, and so is it multiplied by the negative 9. It just happens that when I multiply something by 1, it doesn't change it. So we go 1, factor this. What multiplies to give me 9 and adds to give me 6? X plus 3 squared. If you don't know, look one back from here, because this is the step before, plus 3. So it's x plus 3 squared. What multiplies to give me 9 and adds to give me 6. 3 and 3 multiplied to give me 9. 3 plus 3 adds to give me 6. And then we go 1 times negative 9, which is negative 9, and then my square bracket goes away. As long as I take this number and multiply it by this subtraction one, my brackets go away. So square brackets are gone now. And then plus 8. And so then I'm just left with y equals 1, x plus 3 squared, negative 9 plus 8 is negative 1. Done. We will do so many of these that it won't be as confusing as it is right now in your brain. So what's your vertex? What's the vertex of this graph? Yep. Negative 3 and negative 1, because it's the opposite of this, same as this. Do I have transformations? I know it says sketch the graph and determine any x-intercepts, any intercepts. I want to do transformations. So, do I have any stretches? S. If my a value is 1, I have no stretches, right? It's only if my a value is anything other than 1, 2, 3, a half, whatever. So no stretches. Do I have a reflection? If my a value is negative, I have a reflection. If my a value is positive, I don't. So do I have a reflection? No. Translation, vertical translation first. Do I have one? I look at this number. I move 1 what? Down. Vertical translation, 1 down. Horizontal translation, what? 3 or 3 what? Left or right? Left. So is the opposite, right? So is the opposite equation are the same. Think about it. Your vertex is always at 0, 0. It's now at negative 3 and negative 1. On the original graph, your vertex said 0, 0, the x squared graph. It's now at negative 3 and negative 1. So what did it do? It moved 3 to the left and it moved 1 down. You have to think about it that way. It's always at 0, 0 originally. It's now at negative 3, negative 1. Oh, it moved down 1. It moved 3 left. Okay? Oops. Okay, let's try this one. Once again, we have a 1 in front. So what do? We go y equals square bracket. Write our leading coefficient, which is 1. Bracket. X squared minus 12x. Because if I take a 1 out of both of those, which is what I do when I do this bracket thing, if I take a 1 out of these two, it does nothing. Like if I divide x squared by 1, it's x squared. If I divide negative 12x by 1, it's negative 12x. So that's why these stay the same. Then I add a blank, round bracket, subtract a blank, because if I'm adding a blank, I have to subtract a blank. Square bracket, plus 40. The blank is always b divided by 2 squared. So it's whatever this number is divided by 2 and squared. And if this number is negative, you have to take that. So the blank equals b divided by 2 squared. B is always what's beside the x. So in this case, it's negative 12 divided by 2 squared, which is negative 6 squared, which is 36. I don't skip steps. The reason why I don't skip steps there, I write negative 12 divided by 2, which is negative 6 squared, which is 36. If I don't skip those steps, then my perfect trinomial square is just going to be made with whatever the heck this number is before. So I'm going to put my 36 in for my blanks. And now I actually do the math. How do I drop the square bracket? Well, I go 1 times negative 36 is negative 36. So the square bracket is going to end up going away in a second. So I rewrite the 1. I take this and I say x. What multiplies to give me 36 and adds to give me negative 12? X minus 6. X minus 6, right? If you don't skip a step, it's this number back here. And if you don't know, you can always check if you're right. X minus 6 times x minus 6, like because it's squared, FOIL it out. If you get this back, you're right. If you don't get this back, you did not factor properly, right? X times x, x squared. Negative 6x times negative 6x, or negative 6x and negative 6x is negative 12x. And then negative 6 times negative 6 is 36. Because x minus 6 squared just means x minus 6 times x minus 6, right? If I FOIL these back out, I should get this. If I don't, you made a mistake. Okay? What does everyone forget? This squared symbol. All the time, they'll write x minus 6. And if you forget the squared symbol, it's actually a linear equation, right? You're not going to get the parabola if you forget the squared. So don't forget to put the squared. That happens all the time. My next step to get rid of the square brackets is I go 1 times negative 36. So that's just negative 36. And then plus 40. Then I put these together. So I get y equals 1, x minus 6 squared. Negative 36 plus 40 is positive 4. To determine the vertex of this one is what? Cole? Close. Positive 6 and 4, yeah. Try this one. I don't even care if you do the x-intercepts. I don't want this. I don't want you to sketch a graph. I want you to give me the vertex and transformations. I want you to give me the vertex and transformations. Go. Try this one out. Okay, we'll try these ones. So, first thing we do, pull the 1 out. So we get y equals square bracket 1, the leading coefficient, bracket, x squared plus 10x plus blank, what's the 10? Minus blank plus the back number, 30. Off to the side and find our blank. Our blank is b divided by 2 squared. Our b is always the value beside our x, which is 10 in this case. So 10 divided by 2 squared, which is 5 squared, which is 25. So I go and I put 25 in each blank. So then I get y equals 1. X, what multiplies to give me 25 and adds to give me 10? It's going to be 5 and 5. 5 times 5 gives you 25. 5 plus 5 gives me 10. If you don't remember, the one back if you don't skip steps. So it's x plus 5 squared. Don't forget the squared. If you forgot the squared, remind yourself, don't forget the squared because it happens all the time. Then to drop the square brackets off, we go 1 times negative 25, which is negative 25 plus 30. Now, because it's a 1, it doesn't really do much, right? But when that's not a 1, like a half or a 2 or a 10 or something, it's going to change the ballgame. So we have y equals 1, x plus 5 squared. Negative 25 plus 30 is positive 5. So our vertex is at negative 5 because of this one and 5. And our transformations, stretch, we don't have any. It's a positive 1. Reflection, we don't have any. It's a positive 1, our A value. Translations, vertical translation, think about it. We were at 0, 0, our vertex. It's now at negative 5 and 5. How do we get from 0, 0 to negative 5 and 5? Well, we move 5 to the left, and we move 5 up, right? So just think about how do you move your vertex. So vertical translation, 5 up, horizontal translation, 5 left. Think, it starts at 0, 0, it's now at negative 5, 5. What did I do? Okay, it's the easiest way to think of your transformations, by thinking realistically, not just memorizing. Okay, I was at 0, 0, I'm at negative 5, 5. I moved 5 left, I moved 5 up. Okay, then we're going to do this one. Y equals, take the 1 out, the leading coefficient, 1. And I'm left with x squared plus 4x plus blank minus blank minus 6. Find out what the blank is. The blank equals b divided by 2 squared. B is always what's beside my x. What's beside my x? 4. So I go 4 divided by 2 squared, which is 2 squared, which is 4. Like I said, if you don't skip steps, it's much better because this will get you your perfect trinomial square number. If you skip steps, that's gone, and you have to make sure you factor really, really well. So in my blank, I fill a 4. Then I get y equals 1. Now, what factors to get me, multiplies to get me 4 and adds to get me 4? Well, 2 and 2. And it's right here. So it's going to be x plus 2 squared. If I FOIL that out, I get x squared plus 2x is 4x plus 4. So it does work. Then I have to go 1 times negative 4, always, which is negative 4. Didn't change anything because it's a 1, but if this is not a 1, if this is a negative 1, it even changes it, right? If this is a negative 1, I'd go negative 1 times negative 4, it becomes positive 4. So you have to remember to always multiply that coefficient, that leading coefficient, by that number in the second blank. Because you are multiplying it here too. That's why you do it to both, because if you multiply it here, you're also doing it here. And then minus 6. So we get y equals 1, x plus 2 squared minus 10. So my vertex is at negative 2 and negative 10. Now, if I actually ask you for transformations, remember my original vertex is at 0, 0. It's now at negative 2 and negative 10. What did I do to get there? I moved 2 left and 10 down, right? So then you'd have your transformations. You have the next 10 minutes to work on these questions, and then we're moving on to ones where it's not a 1 in front. It's a negative 1 or a number. Your leading coefficient is a number or negative. So you have 10 minutes to work on this. Okay, so we're going to change this again to standard, because standard form is when you have it, no brackets. General is when you have the bracket, also known as vertex form. Okay, so we want to sketch this in general form. Boy, these words are backwards. General. Okay, we do the exact same steps as last time. We're paying attention, though, because it's a little bit more work because it's not a 1. So we do y equals square bracket. Yeah? Write our leading coefficient still like we did before. The catch on the last one, though, is when we pulled the leading coefficient of 1 out, it didn't do anything, right? If you divide by 1, nothing happens. But we're actually dividing these by 3 to know where to put them behind here because we're taking a GCF out. See that 3 in front? That's a GCF out of those two terms. That's just the greatest common factor out of the two terms. It's so cold in here. Ah. So if I take a 3 out of these two terms, which is what I'm doing, I'm just taking GCF out of the first 3, not the third one, just the first 2, not the third one, just the first 2. If I take a 3 out of here, it's dividing when I take a GCF out, right? So 3x squared divided by 3, I'm just left with an x squared. Negative 12x divided by 3, I'm left with a negative 4x. So last time I took out a positive 1, just positive 1 when you divide by positive 1 doesn't change anything, right? Same thing as before, add a blank, minus a blank, square brackets, put your 11 at the back. So nothing has changed. We just have to realize, hey, we actually divided that 3 out. Like we divided the 1 out, but it didn't do anything. Okay, off to the side, we do our b value, our blank. Our blank is b divided by 2 squared. Our b is always what's beside our x in this bracket. So some people go and try and take this b, but this negative 12 up here, but we're not trying to make a perfect trinomial square with negative 12. We're trying to make a perfect trinomial square with this negative 4, right? So this is the b we take. Oh, my Lanta, where are you when I teach? You're here, but are you really here? I don't know. Okay. So it's going to be negative 4 divided by 2 squared, which is negative 2 squared, which is 4. Please remember to take the sign with. Okay, so if it's negative 4, you need to take the negative with, because when we do our perfect trinomial square, we're going to use the negative 2. If you forget the sign, you're not going to get the right thing. So how do we do this? We write 3. Oops, 4 and 4 needs to go in the blanks. So we write 3, and then we get our perfect trinomial square. X, what multiplies to give me 4 and adds to give me negative 4, which is negative 2. If this is a negative 4, this is going to have to be negative. Because remember, it multiplies to get me this, adds to get me this, squared. Remember, you can FOIL it out and see if you get this back. If you do, you did it right. If you don't, you didn't do it right. Go back, try again. What do we have to remember to do? Multiply this number by this one. Last time, if we forgot to multiply it, it wouldn't have mattered because it was a 1. And you multiply by 1, it stays the same, right? But you have to multiply it here because, look, the 3 and the 4 are being multiplied, correct? We just don't keep it. And then 3 times negative 4 is negative 12 plus 11. So you have to remember to multiply these. That's why we have that square bracket. That square bracket is there to remind you, hey, I need to multiply this number by this number. Once you've done that, square brackets go away. That's why they're not there anymore. And then we can just put these two together. So we get y equals negative 3x minus 2 squared minus 1. It's not, you crazy people who see negatives when they're not there. You just write negatives when you feel like it. It just changes it completely. It's what you do. It's not what you do at all. I don't even know if I wrote negative per se as a negative or if I just kept going with my equal sign. I don't know, but it was wrong. It's not right. Okay, let's go with, I don't want you to sketch the graph. I want you to do the vertex and transformations again. So the vertex of this one is 2 and negative 1. Now, this one actually has a stretch because my a value isn't 1, it's 3, right? So my stretch is a vertical stretch by a factor of 3 about the x-axis, because everything is about the x-axis for you guys this year. And you're going to be super happy about that because next year this is not the case. So enjoy the fact that in grade 11 it is always about the x-axis. Like throw a little party in your head because this is like good times. You don't know it, but next year it's not as good at times. So enjoy your good times now. Okay? Is there a reflection? Is my a negative? No. And you only have a reflection when it's concave down. It's not concave down because my leading coefficient is positive. Now, translation. Vertical translation, horizontal translation. Think about it. My vertex is at 0, 0. It's now at 2 and negative 1. How did I go from 0, 0 to 2 and negative 1? For you guys, 2 and negative 1. How did I go from 0, 0 to 2 and negative 1? I moved 2 to the right and 1 down. So vertical translation, 1 down. Horizontal translation, 2 right. Oops. The very first thing you guys want to always do is always write an x squared x number. So if it's not in that form, which it's not in this next one, you need to rewrite it in that form. Please be quiet. So we're going to write negative 3x squared plus 5x. If you want to, you can put a plus 0 at the back. If you want, because we don't have any number at the back. We don't have a constant at the back. And our constant is always our y-intercept. So this graph is actually going to have a y-intercept at 0. Our first step, take the leading coefficient out. You're going to have to watch yourself because the leading coefficient this time is negative. You take it out of the first two. Square bracket, negative 3. So you divide it out of the first two. X squared, negative 3x squared divided by negative 3 is just x squared. 5 divided by negative 3 is negative 5 over 3x plus blank minus blank square bracket plus 0. As you can see, we're dealing with fractions here, people. They don't go away. You need to deal with them. You're in 20-1. So the blank equals b divided by 2 squared. In this case, b is negative 5 over 3 divided by 2 squared. Now, that's just like saying this. We're paying attention so we're not lost. That's the same as saying negative 5 over 3 divided by 2 over 1, correct? Which we have to say is negative 5 over 3 times 1 over 2. So when you divide by 2, it's actually multiplying by a half. Remember, you always have to flip and multiply when you're dividing fractions. So flip and multiply, flip and multiply. So negative 5 over 3 times 1 over 2. We do not cross multiply. We cross multiply across an equal sign. There is no equal sign in the middle of them. So please don't cross multiply them. Just multiply. Negative 5 times 1 is negative 5. 3 times 2 is 6. So we get negative 5 over 6. And you're not done. Some people are like, oh, great, I'm done. No, that's just inside here. You still need to square that, which is 25 over 36. Please, 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 please don't write the decimal, because the decimal doesn't stop. It's a repeating decimal. You can't just decide, hey, I'll just take 2 decimal places. You can't do that. You can't. It's wrong. So in our blank, we're going to fill 25 over 36. Then we write y equals negative 3. Now, this is where not skipping a step is helpful, because before it'd be like, what multiplies to give you 9 and adds to give you 6? And it was like, oh, it's 3. That's not bad. Now it's like, what multiplies to give you 25 over 36 and adds to give you negative 5 over 3? People cry inside. Don't cry. Just go back one. Let's go back one. What's 1 back? What's 1 back? Negative 5 over 6. That's your answer. So you're going to go x minus 5 over 6 squared. So this is why not skipping that step is helpful, because I just look 1 back, right? Because multiplying to give you 25 over 36 and adding to give you 5 over 3, negative 5 is a little bit dicey. But if you go like that, it's not so bad. Then we have to remember to take this and multiply it. Okay? So what's negative 25 over 36 times negative 3? Do it in your calculator. You can try it out. Negative 25 over 12. Or positive, sorry. So this one here, you guys, this one tricks people out a little bit, because it's you're still taking out a negative 1. So watch. So we get f of x equals square bracket negative 1. Now you're taking out a negative 1. When you take out negative 1s or divide by negative 1s, it changes your signs, okay? So if we take a negative 1 out of negative x squared, we're left with positive x squared. If we take a negative 1 out of negative 4x, we're actually left with positive 4x. Plus blank, minus blank, minus 12. So when you take that negative 1 out of the first 2, you actually make it become positive x squared and positive 4x when you do the trinomial. Okay? Now, when we go off to the side, we want to fill in our blank. It's going to be b divided by 2 squared. B in this case is actually 4, not negative 4. We don't go to this one. We use the one that we want to make a trinomial square out of. So 4 divided by 2 squared is 2 squared, which is 4. So in each blank, we get a 4. So there's 2 ways that people mess up when it's a negative 1. They forget to take the negative 1 out of the first 2 terms. And then what's the other one that they forget to do? How do you get rid of the square brackets? The only way you get rid of the square brackets is taking this and multiplying it by this. Okay, that's the biggest common error. So we're going to get negative 1 multiplies to give me 4 and adds to give me 4, x plus 2, because we look 1 back. X plus 2 squared. And then the common error is to just go negative 4 minus 12 and write negative 16. That multiple choice answer will be there. It will be wrong, but it will be there. You have to go negative 1 times negative 4. That's why you have the square brackets, to remind you I need to multiply. So negative 1 times negative 4 is actually positive 4 minus 12. And so it's negative 1 x plus 2 squared minus 8. So my vertex would be at negative 2, negative 8. If you flip to the next page, the homework questions for that are on the next page. So that's the homework for today, those 2 pages.